Okay, let's give you guys another example. So we've seen this list before in the past. We've seen this before. Now we're going to try and find the limit of this thing here as x tends to 0. But here's the thing: we need a series for tan of x. we looking at our list, we've got everything else apart from tan of x. We've got inverse tan, but we haven't got one for tan of x. We've got one for sine of x. We've got one for sine of x. Sine of x is here. So we've got our series. We've got our series for sine of x, but we need one for tan of x. So in this video, we're going to try and come up with a series for tan of x. In the next video, then we will evaluate this limit. So in this video, we're just going to try and find out the series for tan of x. So start out, but by the way, the series for tan of x happens to be this, all the way to infinity. But let's pretend we didn't know this and we've got to work this out from scratch. So to work it out from scratch, start out with your function, start out with your general series, differentiate this, that will then give you this, differentiate this, that will then give you this. So we would demand the first derivative to match up with the first derivative of this. So we would put 0 into here. We would put 0 into here. So when you put 0 into here, this whole thing here will become 1. This whole thing here will become 1. So at x equals 0, put 0 into here. So that would then everything else here would disappear, leaving you with a1. So a1. So remember, we demand the first derivative to be the same as the first derivative over here. So at x equals 0, the a1 equals 1. By the way, I'm whizzing through this because by now I'm assuming you're able to do this on your own. So I'm just going to whiz through this. So a1 equals 1. So if you look at this here, a1, so a1 here, this is your a1 here, equals 1. So that's why this thing here, the coefficient here is 1. And remember, we also demand that the original function to match up with the original function, with the original series over here. So at x equals 0, you would put this into here. Tan of 0 would be 0. So at x equals 0, you would put 0 into here. So this will disappear. So a0 equals 0. So that's why your a0 here equals 0. That's why you haven't got a constant. That's why 0 plus, and then it starts at x. So this starts at x here. And then remember, we also demand that the second derivative to match up with the second derivative. So we would put 0. So at x equals 0, we would put 0 into here. So this thing here, sine of 0 would be 0. This thing here will be 1 at the bottom. 2 times 0. This whole thing here will be 0. Okay, so looking at this, at x equals 0, we will put 0 into here. So this whole lot disappear. This will disappear. So here we would demand this to be the same as this. So we would demand 0 to be the same as 2a, 2. So divide both sides by 2. So that would then, so a2 equals 0. So looking at this, so when you demand this to be the same as this, a2 here equals 0. So going back to here, a2 here is 0. So that's why you haven't got an x squared here. That's why you haven't got an x squared. Well, that's why you haven't got an x squared here. Okay. So now the third derivative. So hang on, looking at this. So differentiate this. That will then give you this thing here. And then for the third derivative, we would differentiate this. So remember, when you differentiate this, remember the quotient rule. Hang on, let me think. You take away what this thing here. So square this. That will then give you this. Blah blah blah. Differentiate this. That will then give you this. So tidy this up. That will then give you this. And then we would demand and then we would demand the third derivative to be the same as the third derivative of our series. So we would demand this to be the same as this, meaning we would demand this to be the same as this. Okay, so at x equals 0, hang on, let me hang on. So at x equals 0, you would put 0 into here. So this block here will be 1. You've got a sine square here. At x equals 0, this thing here will be 0, making the whole lot here 0. So hang on, let me repeat that. Put 0 into here. This thing here will be 1. So here you will have 2. This whole thing here will be 0. So the numerator will be 2. At x equals 0, this thing here will be 1. So overall, this block here will be equal to 2. That's why you've got this 2 here. Well, at x equals 0, you will put this into here. So everything else will disappear, leaving you with this. So this thing here is really 3 factorial. 3 factorial. You've got A3 here. So A3 here is really a third. Okay, because 2 over 3 factorial. So these two cancel out, leaving you with a third. Well, blah blah. A3 equals a third. So what that means is, remember, A3 equals a third. So going back to here, remember, A3 here is equal to a third. So what that means is this. Hang on. A3 here. Hang on. A3 here is a third. So that's why your x to the power 3 is here, and you've got your third here. This is your third. Okay, and so on. You could repeat the process and take it all the way to infinity. But if you look it up on the internet, your series with tan of x equals this thing here. Okay, so hang on. So yeah, so this is how we would obtain our series, but it takes a long time. Hang on. So this is how we would obtain our series. We would start out with this, differentiate it, start out with this, differentiate it, demand the first derivative to be the same as this, demand the second derivative to be the same as this, the original to be the same as this, and so on. That's how we would do it, but it takes a long time to write this. So when you come to do it by yourself, create a table. It's much quicker. So you start out with this. Remember, you don't know this. So create a table. So create a table is much quicker. So create your table. I will continue in the next video. Okay. So we are now at this table.